Hocam, can I ask something?
Yes.
When will you upload these solutions?
Uh,
Recording video? Yeah.
I will solve the fifth question. Then I will download the Zoom files. Of course, it takes that time. I don't know how many minutes will it take. When it comes, I will need to load them on YouTube. Then after YouTube, I will directly do it, but the process takes some time, and this is the problem. So
Okay.
I don't know how many minutes will it take.
Okay, hocam. Sağ ol.
Share screen. This question. Okay. Can you see example 4?
Yes, hocam.
Yes, hocam.
Okay. This is a branching pipe question. Okay. So the question is given. We have reservoir A, D, E. We have the elevations for those reservoirs. The pipe length is given for pipe BD and for pipe BE. The diameters are given. The pipe length for pipe AB is not given. Okay. And the discharge in the pipe BD is given as 45 liters per second. And what else? F values are given. For all pipes, it's 0.02. And the question has two things that wants us to do. First of all, it wants us to find the direction of the discharge inside the pipes. And in the part B, it wants us to find the length of the pipe AE. Okay. In questions like this, the problem is we don't know the direction of flow, right? Because we don't know the total head at this point B. We know the head at these points, but we don't know the total at that point B. And as you know, the flow goes from higher head to lower head. This reservoir A and D are at a higher elevation, but since a flow is going through this pipe, so it will have velocity head and pressure head as well. So it might have higher head from point A, for example. But as an initial start, we can say, we know flow has to flow one of these reservoirs to this junction point. Otherwise, there won't be a flow, right? So, and since reservoir D has the highest elevation, which means the highest head, because as we did in the previous example, these are open atmosphere. So we will cancel the velocity head and pressure head at point D, A, and E. So since this point D has the highest elevation, automatically it has the highest head. So we can say flow goes from point D to point B. And we can start by using that assumption. So for part pipe BD, the discharge is given as 45 liters per second. And F value is given as well. And so we can calculate the, by the way, for this question, it says ignore the major head loss again, okay? This question, we are ignoring major head losses. So we are dealing with, minor head loss. We are ignoring minor head loss. We are dealing only with the major head loss. So by using this F value, we can calculate the major head loss in this pipe because we know the length, we know the diameter, and we know discharge. We don't know velocity, but we know discharge, so we can calculate the velocity and we can find the major head loss happening in this pipe. So what is the formula for major head loss? It is FL V squared divided by D times 2G. We know F 0.02. We know the length of this pipe BD, which was 1000. We know the diameter is given as 0.3 meters. We know G 9.1. And for the velocity, again, we will write discharge divided by the cross-section area because we know the discharge. So the discharge is 45 liters per second, which means 45 times 10 to the minus 3 meter cube per second. And the cross-section area is pi times the diameter squared divided by 4. At the end, the major head loss is equal to 1.38 meters. We got the major head loss. Now we can write the energy equation between this point B and this point D. So for the point D, as I said, our total head is equal to only the elevation because the velocity and the pressure head equal to 0. And we know the major head loss, so minus the major head loss, and we ignore the minor, as I said, minor head losses. So elevation head minus the major head loss, we will get the total head at point D. So it corresponds to 4.62 meters. So we found the total head at point D. Now we can decide the direction of flow. We accept this point E as a datum. Okay, so we will accept its elevation head as 0 as well for point E and make our calculations according to that. So for the directions, the point D has the highest head as 6 meter. Point A, we have 5.4 meters head. Point B, we have 4.62. And for point E, as I said, it is our datum. So we have 0 head in total. So the direction will be like point D to point B, point A to point B, and from point B to point E. The flow direction will be like that. Did you get this part A? Any questions? Okay, that's good. So for part B, what it was asking, find the length of pipe AB. Okay, for the to be able to find the length of pipe AB, first of all, if we can find the discharge in this pipe, okay, if we can find the discharge in this pipe, we can find automatically the discharge in pipe AB. Why? You may ask why? Because as you said, flow comes from D to B, so like this, and A to B. They meet here, combine, and flow the point E through pipe BE. So if we find this discharge, and if we subtract the discharge in pipe BD from this one, we can get the discharge in pipe AB. So to find the discharge in pipe BE, first of all, we need to calculate the head loss happening in pipe EE, and then we can find it. So how can we calculate the head loss in pipe BE? It's simple. We know the total head at point B, right? And we said we don't have any minor head loss. And we know the total head at point E as well. So when you write the energy equation, I wrote it here. So head at B, total head, minus the head loss will be equal to total head at point E. Total head at point E was 0 because it's our datum. We calculated this total head at point B in the first place, in the first part, which was 4.62. So 4.62 minus the major head loss will be 0. So major head loss is automatically 4.62 meters. So when you know this major head loss, you can directly calculate the velocity. And by using the velocity, you can calculate the discharge, which we were looking for. Let's write the major head loss equation, which is FL V squared divided by D times 2G. So F value, we know the major head loss. We just calculated. F value is 0.02 for all pipes given by the question. Length was 1000 meters. The diameter is 0.4 meters. and of course g is 9.81. From this equation, we get the velocity as 1.34 meter per second. Okay. Then what is the discharge? Discharge is equal to velocity times cross-section area of the pipe. So it is 1.35 times p d square over 4. So discharge is found as 0.170 meter cube per second. So we found the discharge at this point, sorry, in this pipe, and we know the discharge in this pipe. It is given us, it was 45 liters, which means 0.045, yes. Or you can say this is 45 liters per second, and we found here is 0.170 meter per second, which means 170 liter per second. So when you subtract them, you can find the discharge in pipe AB. So you can find as 125 liter per second, which means 0.125 meter cube per second. Okay, you find the discharge in pipe AB. Again, like how we did here, from discharge, we can go back the velocity by dividing it by the cross-sectional area. So 0.25 meter cube per second divided by the cross-sectional area, pi times d is 0.5 for pipe AB given by the question, and you'll get 0.64 meter cube meter per second as the velocity in pipe AB. So from this one, by using this velocity, how we can calculate the length of the pipe is if we write the energy equation between point A and point B, we can find the major head loss. It will be like we did in this pipe. We will find the major head loss, and since in the major head loss equation there is a length, once we find the major head loss value, the value of the major head loss, we can calculate the length of the pipe. So let's do it quickly. I wrote the equation between point A and B, which is head at A minus the major head loss will be equal to head at point B. So elevation was 5.4 meters, which corresponds to our total head since it's open reservoir. 5.4 minus the major head loss. I directly wrote the equation of the major head loss, so we can take length directly, and will be equal to head at point B. We calculate the head at point B in the first part, which was 4.62 meters. So this is our final equation. Everything is known, only unknown is length. So from this one, we can calculate the length as 934 meters. And this is the example 4. Any question about part B or part A? Doesn't matter.
Hocam ben sorabilir miyim?
Tabii.
Enerji equation'ı yaparken B'de neden velocity head ve pressure head'i dahil etmiyoruz?
Hangisinden? Buradakini mi diyorsun?
Evet, evet.
Your friend is asking here why we don't add when we write, why we don't add the velocity and pressure head for the point B when we are writing the energy equation. The thing is, actually we are adding. This is the total head at point B. This 4.62 is the total head at point B. It is not the elevation head. I don't know what is the elevation of this point. Here in the part A, I calculated the total head at point B. So total head means pressure head plus the velocity head plus the elevation head. So this 4.622 is the summation of all the heads at that point. So we are actually adding it inside it. Anlayabildin mi? Ne demek
Evet,
istediğimi?
tamamdır hocam, çok sağ ol.
Canım. Another question? Okay, this was the fourth example. we are left with one final example. Then we will end this session. But before that, let's give a, if you're tired, we can give 10 minutes break as well. It's up to you. Do you want 5 or 10 minutes break?
5 is okay, I think.
5 hocam.
Okay, then 5 minutes break, then we will solve our final example. See you in 5 minutes.